You know, the buildings that we see all around us every single day aren't just random shapes. They're actually elegant physical answers to some very specific questions. So let's dive in and start decoding the hidden logic of the structures we walk past all the time.
It all starts with a pretty simple question, right? Why doesn't a towering skyscraper look anything like a sprawling apartment block? And for that matter, why does neither of them look like a massive warehouse? It seems obvious, but the reason why they're so different, well, that's the key to understanding pretty much everything about construction.
All right, first up, let's picture the classic apartment block. The problem it's trying to solve is how to house lots of people in separate, identical units. So the solution? A wide, rectangular form that's basically just stacking these repeating boxes side by side and on top of each other. It's all about maximum efficiency.
Now let's flip that on its head and think about the skyscraper. This is all about verticality. It's about reaching for the sky, usually with a sleek, often glass-covered exterior that just screams height. And then, of course, we have the warehouse. It's this huge, single-story building that's defined by one thing: its vast, completely uninterrupted interior space. So right there you have three buildings and three totally different forms.
So, here's the big idea. Every single building is a solution to a problem. And here's the cool part. If we can understand the problem it was designed to solve, we can decode its structure. It's like being a detective for architecture.
Okay, let's start with our first challenge: building with boxes. How do you efficiently stack a whole bunch of identical living units? We're talking apartments, hotels, student dorms, that kind of thing.
So here's the specific puzzle. You have to build this housing, and it needs to be fast and cheap. Plus, every single floor plan is an exact copy of the next. So how do you build that in the smartest, most efficient way possible?
Well, the answer is a really clever method called cellular construction. And the core idea? It's genius in its simplicity. The walls themselves do all the work. The entire load of the building, all that weight, is carried by a grid of walls, which creates this series of super strong, self-supporting boxes.
So the strength of this whole system comes from that rigid grid of load-bearing walls. It's absolutely perfect for buildings that are already divided up into lots of small rooms, like our apartment block, because the structure and the room dividers are actually one and the same thing.
But there's a catch with building with load-bearing walls. It has one major limitation. You can't go very high. So that brings us to our next big challenge, the problem of height. If you want to build a skyscraper, you need a totally different playbook. And the goal isn't just height. It's also about creating these big, open, flexible floors that aren't all cluttered up with thick, structural walls.
The solution was an absolute game changer: rectangular frame construction. In this method, the building's entire weight is supported by an internal skeleton of columns and beams, and the walls? They're basically just hanging off this frame, almost like a coat.
And this is where things get really cool, because that skeleton is doing all the heavy lifting. The external walls, the cladding, can be incredibly lightweight. A lot of the time, they're just glass. This separation of structure and skin is exactly what allows buildings like the Burj Khalifa to soar to such unbelievable heights.
So let's just nail this down, because it's the crucial difference. In cellular construction, the walls are the structure. In frame construction, the skeleton is the structure. One is like stacking a bunch of strong boxes, the other is literally like a skeleton wearing a coat.
Okay, so we've gone up, now let's go wide. Our next challenge is all about creating these enormous, uninterrupted indoor spaces. Think about a giant warehouse or a sports arena.
And the problem here is pretty straightforward, isn't it? How in the world do you put a roof over a massive area without needing a forest of support columns on the inside? You've got to somehow span a huge horizontal distance.
And the answer is the portal frame. It's a simple idea, but it's incredibly powerful. You have a series of strong, rigid frames. Think of them like giant goalposts that are placed in parallel. They take the entire weight of the roof and transfer it outwards and down into the foundations, leaving the inside completely open.
So why is steel the go-to material for these frames? Well, it all comes down to its incredible properties. Steel has amazing tensile strength. It resists being pulled apart. And that property is exactly what allows for those breathtaking, column-free interiors you see in modern airports and stadiums. On top of that, it's tough and it's hard, which makes it durable enough for a busy construction site.
But there's another secret weapon here, and that's prefabrication. The different parts of the frame are all manufactured with super high precision in a factory, and then they're just shipped to the site and bolted together. This makes the whole construction process incredibly fast and efficient.
So we've got solutions for stacking things, for reaching great heights, and for creating massive open spaces. But what about the biggest challenge of all? Time. This brings us to a totally different kind of problem. Not building something brand new, but preserving something really, really old.
You see, for historic buildings, the whole philosophy just flips. It isn't about building fast, it's about preserving what's already there. And this quote really sums it up perfectly. Frequent, careful maintenance is ultimately more cost-effective, as it prevents small problems from escalating into major, expensive structural failures. Basically, a little bit of care now saves you a fortune in repairs later. Let's take a real-world example, Westminster Abbey. To maintain a building like this, you don't need the latest machinery, you need ancient skills. You need a stonemason who can still carve and repair the facade by hand. You need a blacksmith who can forge and fix the historic iron window frames, because working with traditional wrought iron, which has to be heated and hammered into shape, is a completely different ballgame than just welding modern steel.
All right, so there you have it. We've just filled up our builder's toolkit. We've got cellular construction for efficiently stacking boxes, the rectangular frame for reaching for the sky, the portal frame for creating those huge wide open spaces, and finally, the specialized heritage crafts that are needed to preserve our past.
Each one of these methods tells a story about the problem it was designed to solve. So the next time you walk down the street, I want you to really look at the buildings around you. Don't just see shapes, try to see the solutions. Ask yourself, what stories are they telling you?